So these first few problems on 8.5 about exponential equations are just kind of a warm-up I would have you do in class. A lot of students will struggle with this because they'll try to add because they see times, they'll try to minus because they see divide. But what I do know is that this is, if I set that equal to x, log base 9 of 81 equals x, identify my by and x, 81 equals 9 to the x power, well this simplifies to 2. Same thing over here, I've got equal that to x, b, y, and x, so I've got 3 equals 9 to the x power. Remember how we said that if it's 2 going this way, they go in the other way, it's 1 over 2. So I'm multiplying those, and I just get 1. Similarly here, again, if I set that equal to x, b, y, and x, I get 16 equals 2 to the x power, so that simplifies to be 4. This b, y, and x gives me 8 equals 2 to the x. This simplifies to be 3, and 4 divided by 3 is 4/3, or 1 1/3. Negative exponents, flip it. This is something that we haven't really done before, but negative exponents flip it. So the first thing I can write here is 1 over 125. This is the power, this is the root. Before we just had 1/3 power, this is the power, this is the root. Okay? Now this becomes really easy when you realize what this is, to the 1/3 power. Now, could I just do this to a calculator? Yep, but I don't want that. I'd rather have it be 125 to the 2/3 power, so you can figure that out. The cube root of 125 is 5. I haven't done that yet. And then I just square it. Don't worry too much about that kind of problem. But we should be able to do these if we really think about it. Okay? So, what are opposite operations? What are inverse operations? X squared and square root of x are opposites. They're inverses. Okay? So are that, and you guessed it, that, exponentials and logs. Okay? So to solve exponential equations where the exponent includes a variable, like you can see here on this first example, like similarly 5 to the 3x equals 20, we can take the logarithm on both sides to kind of do the opposite. So, you know, like for instance, if I have x plus 6 equals 5, to solve that we would do the opposite. We'd minus 6 to both sides. If I have 3x equals 9, we would do the opposite. We would divide. Well, the opposite of an exponential is a log. Maybe I'll just underline that word log in logarithm. So, to do that, let's log both sides. So I've got log of 7 to the 3x power equals log 20. Again, log without any number there is just base 10, if you remember that. Now, how can I solve this? Well, if you remember the properties of logs, this 3x can come out front here as a multiplier. So I got 3x log 7 equals log 20. So if I just had, let me see if I can do this on camera. 3x equals 20. You would solve that by dividing by 3. Well, it's the same thing here. To get, this is 3 times x times log 7. So to solve for x, I just divide everything by 3 log 7. Now when you do that, ladies and gentlemen, you need to have all of that in parentheses, like so. So try it a second, go in your calculator, log 20 divided by parentheses 3 log 7. And parentheses equals. You should get 0.513. Okay, we're going to take everything to 3 decimal places just because it's easier to do that way. Okay, and that is the answer. Now if you remember, on our graphing calculator, we can do this as well. We can say y1 is the left side, y2 is the right side. You plot the graphs, and what's going to happen here is it's going to be a graph that kind of looks like this. Okay, and you're going to have y equals 20 kind of is a horizontal line through 20. So this point is something, comma, 20. And again, if you go in your calculator, you graph those, and you go second trace. Remember that second trace. This is how you can always check your answer. And then 5 for intersection, and then enter, enter, enter. Okay, move your cursor closer to the point. But because there's only one point of intersection, you really don't even have to do that. It's just enter, enter, enter. And you would get 0.513. We would do this in class today if you were in class as well. Okay? So now that we know how to do this, let's just try a few more. Let's try number 1 together. Log both sides. That's always going to be the first step. Okay. The second step is to always bring the entire exponent over here. So I'm going to have x plus 2 log 5 equals log 400. And this is a little deceiving because it looks like x plus 2 log 5. But that entire exponent is on its own. So to solve this, well, this would be like 3x equals 400. What do I got to do? I divide both sides by 3. So let's divide both sides by log 5. Okay, those will cancel. And I'll just have x plus 2 equals, well, when you divide those, you get like 3.72. Okay, well, how do I solve that problem? Real simple. Sorry, I didn't realize you couldn't see that. Again, let me go back over this. I bring the exponent out front, in parentheses, divide by the log 5, and then just minus 2. Don't even need a calculator for that. 1.72 is my answer. So I take that back. We're going to do everything kind of to 2 decimal places, not 3. Okay. You can check this in a graphing calculator. You don't have to, but you can check in graphing calculator by doing this thing. Okay. For the next problem, I want you to try 2, 3, and 4. They are very similar to the 2 problems we've already done. If you have a question, go back and look at that. Press pause, try 2, 3, and 4, come back and check your work. I'm going to kind of start doing these as one step here. I know I got to log both sides, but I also know this is going to end up coming out front. So let me put the 2x there. And so this one was just very simply done. I'm going to do the same thing here. X plus 4 log 3. Then it just kind of becomes the same thing. Right here, they're all on one step. There's nothing that I need to do otherwise than get rid of 2 and log 6. So over here 2 log 6. Now if you were to just divide this by log 6 first and then divide by 2, you get the same answer, okay, which is 0.85. This one, again, divide by log 3. I get x plus 4 equals 4.20 and minus 4. X is 0.2. Alright, so how do we know that these answers make sense? Well, we can plug it back in, you know, like for this problem. 3 to the 3rd power is 27, 3 to the 4th power is 81, 3 to the 5th power is 243. So, to get 101, it can't be 3 to the 4th power, that's 81. So it can't be 3 to the 5th power, that's too high. So this value should be somewhere between 4 and 5. If I plug in that, I get 4.20. Well, that makes sense, that's the answer, okay? So you can always kind of estimate, like, what about is it? Like here, 3 to the 1st power is 3, 3 to the 2nd power is 9. So if I plug in 1.26, 3 to the 1.26 power, well, that equals 4, give or take. Okay? Alright, let's go to the next page. When are we ever going to use this? I've had some students actually ask me this. So let's talk about how we're going to use this. Exponential growth and decay. We get y equals ab to the x power. Compound interest, if you don't remember that one. 1 plus r over n to the nt power. Okay? How long? The question is asking, this is a real type question for money. If I'm trying to get $6,000 and I only got $4,000, how long would it take for me to grow that money if I invested at 6%, which is my rate, compounded monthly, which remember that's my n of 12, and my rate, remember we moved the decimal over 2 places, is 0.06. I want to see how long it'll take 4,000, my principal, to grow to be 6,000, which is the total amount I want. So let's start plugging some of this stuff in. I've got 6,000, plugging it into this equation here, equals 4,000 times 1 plus the rate, 0.06, over the number of times compounded, which is 12, to the 12, well, t is what we're trying to find here, right? This looks hard, but now that we know the rules of logs, it's really not that bad. start doing some of this work in your calculator. We can divide this, we can add the 1. So really, this is 6,000 equals 4,000 times 1.005 to the 12t power. Now if you notice on the other ones, it was just something like that I would solve, and I'd log both sides. But I need to simplify this first. I need to get rid of this before I do anything else. So let's divide both sides by that 4,000 to get rid of that. I'm going to divide this side by 4,000 as well. That happens to give me, I'm going to put it over here, 1.5 equals, well, 1.005 to the 12t power. I just got rid of the parentheses because I don't have anything to multiply by anymore. Now I can log both sides. Log this side, log this side, bring the exponent out front, so I'm going to put the 12t right here, and solve this like we did everything on the front page. Get rid of the 12, get rid of the log, 1.005. Those will cancel, those will cancel, and make sure I put it in parentheses. Divide that in your calculator. What you should get is 6.77. By the way, this is the equation. I suppose I probably could have written it in the equation line. What are we talking about? 6.77 what? Not months. It's compounded monthly, but over 6.7 years. Okay. Same question. How long will it take 4,000 principal to double, which means my A is double that, 8,000, if the rate is 0.06 and it's compounded monthly? Same kind of thing. We're going to set up the same problem. 8,000 equals 4,000 times 1 plus 0.06 over 12 to the 12t. I already know that that's 1.005. I also know I got to divide both sides by this 4,000. So I get 2 equals. So now I'm really to this step, again, where I can log both sides. So if I log that side, I'm going to log this side and pull the 12t up at the same time, just to save myself a step. And again, I'm going to divide by the same thing I did last time. I get t equals 12 log 1.005, and I end up with, well, 11.58 years, which makes sense. This is less money than this, so it's going to take longer to get to that amount of money. Okay. Now here's the thing. Based on what we just did, look at what happens when I divide. When I'm doubling it and I divide, I got a 2 here, right? So I don't even need to know the initial amount to calculate how much time it takes to double something. If I have to double my investment and the money is at 4% compounded quarterly, let's plug this stuff in. Well, if I have $1, that's my principal, to double that, it would be 2, right? So 1 plus 0.04 over 4 to the 4t power. Okay? Now, I divide both sides by 1, it just goes away. 2 divided by 1 is just 2. I'm going to simplify this and log both sides at the same time. So log base 2, or log of 2 equals log of 1.01 to the 4t power. Remember, I can pull that up here, put my 4t there, and just divide by everything that's not t. Okay, those cancel, those cancel. Put this in parentheses and divide it, and you'll get 17.42 years. Here's the thing. Why is this more than that when it was still double? The biggest reason is not because it's quarterly, but because the rate is lower, 4% compared to 6%. Okay? So we'll do this last problem together. I would have you do this in class to become half its value. So really take half of that. That's my A. That's my P. Depreciates gives me my rate, 16%. We'll talk about that. Per year just means n equals 1. Depreciating at 16% means I got to go 100 minus 16%, which is 84, and move the decimal over 2 places, right? So I got 25,000 is my original amount times 0.84 to the nth power, to the t power, excuse me, to the t power. And the reason I did that is because it's just per year, okay? technically this is a y equals ab to the x problem. Okay? Let's just leave it at that. This equals, well, half of that, which is 12,500. I don't even need to write all this here. I don't, because I still divide both sides by 25,000 like I did before. Look what happens. This divided by this is 0.5. Well, it should be. When it was double, there's a 2 there. When it's half, there's a 0.5 there. That's the way it works. Equals 0.84 to the t power. Log both sides. Bring the t over and just divide by log 0.84. Okay. I get 3.98 years. Okay. Again, this is the equation that would have went there. Okay. Your homework is the next 2 pages. Okay. Trying to go through here and see if there's anything that's kind of confusing, which there is. Number 13, I'm going to help you set up number 13. Okay. Number 13 is a problem that is going to be in the form of y equals ab to the x. Okay. So I'm starting with 40 hamsters. That's my initial amount. So let's plug that in here. It triples, so that's my b. Every 8 years, we'll get to that. When will the population be 1,000? So 1,000 is going to go here. What goes here? If it's every 8 years, and I said over 32 years, you would know to divide 32 by 8. If I said every 40 years, you would divide 40 by 8. If I don't know how many years it takes, which is what we're trying to find, you would take the years t and divide it by 8. So, again, do all the steps. Divide by 40 first. Get your number here, equals 3t to the 8th. It's 25, by the way. Log both sides, pull that out, and once you divide both sides by the log of 3, you get t over 8, so you know how to solve that. If I have t over 8 equals a number, to solve it, you just times both of them by 8. That'll give you your answer here. Okay? Alright, so your homework is 1 through 16. Please work on that by tomorrow. Have a good day.